Okay, now this unit we're going to be looking at simplifying radicals. So let me start just by looking at or what a radical is what we have known so far as a square root. It's just that in algebra 2 we deal with what if it's a cube root, what's a fourth root, a fifth root. So I want us to start calling this radicals instead. So far we're familiar with the perfect squares, right? I could ask you guys, what's the square root of 4? Basically, which number multiplied by itself equals 4? And you guys should probably say 2. And then we have the square root of 9. The square root of 9 is 3. The square root of 16 is 4. Right? The square root of 25, the square root of 36, 49, 64, right? Go on and on. We're familiar with the perfect squares. Now we're going to learn how to simplify. Now, square root of 18 is not a perfect square, right? I'm going to be looking at let me zoom into question number 1. I'm gonna work questions 1 through 8. So question number 1. Let me worry about the radical first. Now, square root of 18 is not a perfect square. However, I'm gonna say, let me multiply this. Let me have the 3 outside. Now, square root of 18, I'm gonna split it into 2 radicals, okay? Now, 18. Let me think of 2 numbers that multiply 18. However, so it's not just any 2 numbers. However, one of the 2 numbers has to be a perfect square. So you guys remember the list of perfect squares. I know some of you guys might be, what about 3 times 6? 3 times 6 is 18, but neither of them is a perfect square. So no, because at 8, I'm thinking of a multiplication that equals 18, but one of them must be a perfect square. So in this case, let me go 9 times 2. Okay, the square root of 9 simplifies to 3, right? I'm trying to break this into simplifying perfect squares. Now, square root of 2 cannot simplify anymore. So my answer in this case is going to be, let me change this to red so we don't get confused. It's going to be 9 radical 2. Okay, the 9, where did the 9 come from? I multiplied those 2 numbers. One thing I'm going to keep in here, whole numbers with whole numbers, radicals with radicals do not mix and match, okay? So that's where I got the 9. I multiplied those, right? Square root of 9 became a whole number. Okay, so 9 radical 2. For us to begin with, I'm going to give it to you as a multiple choice, but later on, the way we're going to type this, I'm going to ask you to go 9 radical 2. So we're going to start calling this radicals instead of just square roots. Again, in algebra 2, which is soon for you guys are going to do, what if it's a square root? What's if a cube root? What's a fourth root? So we're just going to call this radical. So 9 rad 2. Okay. Now looking at here, question number 2. Let me red again for the work. Oh no, I did blue, right? So let me switch blue for the work so we don't get confused. So there's a 5 on the outside, and I'm just going to leave a 5. 175. Okay, let me break this into 2 radicals. I'm thinking 2 numbers that multiplied are equal to 175. One of them has to be a perfect square. In my mind, I'm thinking 25 times 7. I know the square root of 25 is a perfect square. That becomes a 5. Now, square root of 7, nothing I can do. So my answer, let me go in red for answer, is going to be 25 square root of 7. And the 25, again, I multiply these whole numbers. So if you had to write it, or it's a multiple choice, you can identify 25 radical 7. But again, in the future, as soon as tomorrow, it will be 25 rad 7, 25 radical 7. Again, today I just want you guys to know how to simplify. So We'll go simple. Now let's take a look at question number 3. Let me come back to blue again for work. There's the 9. It's outside, it's a whole number. Now 63. Two numbers that multiply equals 63. One of them has to be a perfect square. 9 times 7. I know the square root of 9 is 3. And square root of 7, nothing else I can do. So my answer will be 27th radical 7. And that 27, again, I multiply those two numbers. Take a look at number 4. All right, there's a 4 on the outside. Now, interesting with 64. Okay, some of you might be, all right, let me split this. I'm going to go 4 times 16. I know the square root of 4 is 2. I know the square root of 16 is 4. There's no more radicals, right? Everything cancels out. That means the square root of 64 was a perfect square to begin with. It's okay, we split it, because I know eventually I had to multiply these numbers, right? I'm going to multiply those out. 2 times 4 is 8. Yeah, that was the square root of 64. If you realize that it was a perfect square to begin with, well, awesome. Now multiply with this 4, because I had to multiply them all out, right? 4 times 2 times 4. My answer in this case is 32. I don't have a radical in my answer because I had a perfect square. Now, let's talk about multiplication. Okay, one thing, we can simplify my radicals first and then multiply it, or we can multiply it and then simplify. Let me show you what I mean with multiplying. Well, simplifying first. Square root of 12, I'm going to break that as 2 radicals, right? 4 times 3. Because I know the square root of 4 is 2, right? It simplifies to 2 radical 3. And then times, there's a 4. And then this other 12, I'm going to break this as 4 times 3. So I have that 2. Now, when I multiply whole numbers, 2 times 4 times 2 is 16, right? So I have 16 radical 9. Oh, the 9. Where does the 9 come from? I multiply my radicals. So notice I multiply my whole numbers. I multiply my radicals. Whole numbers go with whole numbers, radicals with radicals. Do not mix and match. However, square root of 9, that becomes a whole number, right? 16 times 3 is 48. Notice how I simplify first, and then I multiplied. What I meant at the beginning is like you could have multiplied to begin with as a 4 times the square root of 144. Right? There's a 4 on the outside, and then 144 because I multiplied my radicals. To be honest, I prefer to simplify first. Now, question number 6. Nothing I can do, right? None of my radicals can be simplified. Nothing I can do. Okay, so let me multiply here. When I multiply my whole numbers, -3 times -4, that's 12, right? When I multiply my radicals, that's 6. My answer is 12 radical 6. I ask myself, can I simplify my radical more? Can I split it as in 2 radicals where one of them is a perfect square, right? Can you split this into 2 radicals, 2 numbers that multiply equals 6, but one of them has to be a perfect square? I know to my mind comes 2 times 3, but the 2 nor the 3 are perfect squares. So nope, that is as low as I can go, 12 radical 6. Again, for today, 12 radical 6. In the future, 12 rad 6. So I'm giving to begin with, I'll give it to you as a multiple choice, but eventually, and eventually is as soon as tomorrow, eventually I want you to know how to type in radicals. I also want you to know how to read instructions. Pay attention to the instructions. Question 7 and 8, squared each radical. Basically, when I say squared, I'm asking 2 radical 5 times 2 radical 5, right? When you square a number, you multiply by itself. So 2 radical 5 times 2 radical 5. That's going to give me 4, because I multiply the outside numbers, 4 radical 25. I think I can do better than that. The square root of 25, isn't that 5? So when I multiply these two numbers, 4 times 5, isn't that 20? Cool. Let's take a look at question number 8. When I ask you to squared, I'm basically asking you to go 3 radical 7 times 3 radical 7, right? Multiply it by itself. When you multiply the whole numbers, you get a 9. When you multiply the radicals, you get 49. Square root of 49, that's a perfect square, right? Square root of 49 is 7. Now I have 9 times 7 because I have two whole numbers, 63. In this case, my answer doesn't have a radical. Interesting part is when you've squared radicals, when you square roots, in this case, you're not going to have radicals in your answer. You're going to have a whole number. Okay, cool. Let's leave it at that. That's what we did today.